Good morning, class 8 students. Welcome to our second class of the second video. And we are again starting a portion from chapter 3 of Elements, Compounds and Mixtures. We saw that in video 1, we studied about elements, we studied about the compounds, then we studied about molecules, we studied about homogeneous materials, we studied about metalloids, and we studied about heterogeneous and homogeneous material. We studied about compounds and their characteristics. So this is all that we studied yesterday. And we see that we also covered some of the details about noble gases and other compounds. Today we go on into the characteristics of the compounds. And we see that compounds, they are, for example, carbon dioxide. These are having more than one element, like carbon dioxide contains carbon, oxygen. Water, it contains hydrogen and oxygen. All these are compounds. And we have ammonia, which contains nitrogen, one nitrogen and three atoms of hydrogen. So in characters of the compounds, we see it is a homogeneous compound in nature because there is a fixed composition between the elements of the compound. It has fixed composition by weight. For example, in water, we see that we have hydrogen and oxygen, two elements combining together. And these two combine in a fixed ratio. Their fixed ratio in water never changes. That is why water is always homogeneous in nature. And how do we find out the fixed ratio of water? By their mass. The atomic mass of hydrogen is 1. We all know that, children. And so we see that in H2O, if we multiply 1 with the 2 given here, 1 2s are 2. So that means hydrogen that is present is 2 atomic masses of hydrogen in H2O. And oxygen present is oxygen has got atomic weight as 16, and we see only one oxygen here, so 16 is the atomic weight. Now we put the values in this particular compound. In place of hydrogen, 2 atoms of hydrogen, we put the calculated mass as 2, and whereas in place of oxygen we use the mass 16. So 2 ones are 2 and 2 8s are 16. 2 divides 16. So we have the fixed ratio of 1 is to 8. Then we come to another characteristic of compound. That compound is formed from its elements by chemical reaction only. These elements, they stick together by chemical reaction only. We see that the constituent elements, for example, in water, hydrogen and oxygen, or a compound, they cannot be separated by physical means. We cannot pull them out, hydrogen and oxygen, or we cannot hammer to pull out hydrogen and oxygen from water. So a chemical compound can be broken into its component elements by chemical methods only, children. Only we can use chemicals to break down a certain compound, for example, water. Then we see another characteristic of compound. The properties of a compound are different from those of the constituent elements. For example, in water, we see there are 2 elements, hydrogen and oxygen. Now, if you look at hydrogen, children, hydrogen is a highly inflammable gas. Very quickly, this gas starts burning. It's highly inflammable. Whereas oxygen is a supporter of combustion. Oxygen is a gas or an element which helps in burning. But The combination of these two elements, hydrogen and oxygen, makes the character of water very different. It becomes a fire extinguisher. It is able to put out the fire. Then we see another characteristic of compound is the formation of a compound is from its elements is accompanied by energy changes. Now we can understand how energy changes take place in the formation of a compound by taking examples of exothermic reaction, wherein light and heat comes out in this reaction. For example, many times we burn candles, and when we burn candles we see light and we see heat coming from top of the flame of the candle. Hence we can classify this under exothermic kind of reactions. Again, we see that a compound is formed by also absorption of energy. For example, during process of photosynthesis, when plants make their food, plants absorb energy of the sun. Is this clear, children? In endothermic reaction, we see that during process of photosynthesis, plants absorb energy from the sun. Hence, they are classified under endothermic reaction because plants absorb energy from the sun and then are able to make food with water and in the presence of chlorophyll. Then we see another characteristic of a compound, that the compound has its own specific characteristics. Its melting point, its boiling point differs from one compound to the other. Now, what are mixtures? We have seen about the characteristics of compound. Now let us see what mixtures are. From the very name as it suggests, mixture is mixing two different things together. For example, children, we can mix sand and sawdust together. We can mix sand and soil together, which will be a mixture. So mixture is obtained by mechanically mixing two or more substances, and these two substances can be elements or they can be compounds. And the mixture are in any proportion. We had seen that in compounds, the elements, they were in fixed ratio. Like in water, it was 1:2. But we see 1:8 we had seen in water, but we see in mixtures it can be any proportion of mixing of elements with elements or elements with compounds. For example, let's see a mixture. Air is a mixture of so many gases we see in our daily life: nitrogen, oxygen, carbon dioxide, water vapor, etc. So many gases are there in air. Then we see smoke is also a mixture. Smoke comes out of chimneys, smoke comes out of industrial waste. So smoke is a mixture of carbon particles and the air which is around it. Then we see gunpowder. Gunpowder is also a mixture of three things. One is niter, or it can be known as potassium nitrate, and sulfur and charcoal. These three make a mixture of gunpowder. Then we see brass is a metal which is a mixture of copper and zinc. These two metals, copper and zinc, they together are mixed to form brass. Then we see there are different types of mixtures. One is a homogeneous mixture, another is a heterogeneous mixture. Now, what are homogeneous mixtures? A homogeneous mixture in which, let us see here, the homogeneous mixture. Now, here we see the example of a homogeneous mixture. We see NaCl here, and we see that the solute particles of NaCl, they are very evenly mixed with water, so that we cannot differentiate between the water particles and the particles of sodium chloride. So this is a homogeneous mixture. This mixture in which the different constituents are mixed uniformly, or they are mixed very nicely with each other and has the uniform composition throughout. Such mixtures are called homogeneous mixtures. Brass is also a homogeneous mixture, and through brass we know coins are made. We cannot tell by looking at a coin that this portion of the coin is copper and the other portion is zinc, because they are very evenly mixed with each other to form brass. Then we see that an aqueous solution of sodium chloride is a homogeneous mixture of sodium chloride with water. Now we come to heterogeneous mixtures. Heterogeneous mixture is one in which the different constituents are mixed uniformly. We see here very nicely the constituents are mixed and does not have a uniform composition throughout, is called a heterogeneous mixture. Like soil in water, we can see the particles of soil separated from water, so they are not evenly mixed. Soil is and a heterogeneous mixture. We also see a mixture of common salt, sand and sulfur mixed together. Now this is also a heterogeneous mixture. But we see that there are other solutions which are very evenly mixed with each other. Like one is known as a true solution. Now what is a true solution? True solution is one in which the size of the solute or the solid particles that are mixed in water, the size of the solute particles is so small that it mixes evenly in the solvent particles and is perceived as a single component. When we mix salt, NaCl, a pinch of salt, into water and we stir it nicely, then we cannot make out the difference between particles of salt, NaCl, and the solvent water. Then we see a colloidal solution here, children. When the solute particle size is greater than the particles in true solution. Here is a true solution, but we see that the solute particles or the solid particles, they are much greater, much bigger in size than the solvent particles and can be seen separately. We can also see the particles separately in water, but the particles become an integral part of the solution and cannot be filtered. Like for example, milk, it cannot be filtered. Every time we try to filter it, we will see that it will bring out milk only from the other end of the sieve. So this is an example of colloidal solution. So children, we will study another example regarding this in the next video. So wish you all the best. Have a good day. Thank you.